my name is Dr. Chuck Fiddler from Wheelock College, and welcome to the Out of School Time video focusing on inquiry science. It's great to have you here today. This video should give you some insight into teaching inquiry-based science to your after-school students. This video is part of an online out-of-school professional development series, which will allow you, an educational professional, a chance to begin this workshop with some insight into inquiry science. As you move through the modules and think about your own work, remember to have fun, ask plenty of questions, and enjoy being a learner. Well, I think all systems are a go, so let's jet over to the classroom and have some fun.
This is your captain speaking. We're getting ready to land. Welcome to Inquiryville.
With all the buzz around inquiry science, I'm interested to hear what others think this actually means.
What does science inquiry mean to me? I'm not entirely sure, but I know it involves asking questions and doing problem solving rather than getting the answers being handed to you.
What does science inquiry mean to me? Science inquiry is student-centered. Students should be asking questions and trying to figure things out through trial and error. They should be collaborative. They should be working together to try to get to the right answer, even if they start at the wrong answer. It's exploratory. It's finding what works and finding what doesn't.
What does science inquiry mean to me? I would say it's getting students to pose their own questions and investigate them.
What does science inquiry look like in my science classroom? Well, we're normally given a set of instructions to follow, along with a list of materials, and then we have to solve the problem. I don't always get it right, and if I don't, we try again.
So what does science inquiry mean to me? I honestly don't know.
As you can see, there are some different ideas about inquiry science, but the research suggests students who engage in inquiry may gain a better understanding of science. And furthermore, those teachers who can provide opportunities for their students to engage in inquiry often serve more as a guide during a classroom investigation. So, can you engage in this process in the after-school classroom? Absolutely. Let's check out some scenarios to get things going. Let's take this traditional paper airplane activity. Ask the students to follow the directions to create a paper airplane by folding the paper on the numbered lines. Once finished, students will compete to see whose plane flies the farthest. Students should work in pairs and name their aircraft. Did you collaborate on your design?
No, I just kind of did it myself.
Did you try different plans?
I'm not really sure.
Did you record any information about your investigation to share with your friends?
No, I didn't write anything down.
Did you feel like you could make any changes to the airplane design?
No, I just followed the worksheet.
How did you feel during this activity?
I felt frustrated because I think the worksheet is wrong, so I just did my own thing.
Based on your observations, does this activity look like a student-centered inquiry investigation? Why or why not? Think about this at home for a moment and reflect with your peers on your own projects. Let's fly by that activity again and see how we can make it more inquiry-centered. Instruct your students that they have a design challenge. They must use the following materials to construct an airplane which will fly the farthest using only the materials available. In addition, students can have numerous opportunities to try their design in a secret test lab, maybe in the hallway, as long as they keep track of their design in their science notebook. Students should work in pairs and are allowed to use multiple pieces of paper. In addition, they can use up to a foot of tape, 25 paper clips, and 1 rubber band. Do your students seem excited and ready to begin? So what are some of your design elements you're making on your plane?
I wanted the wing to taper so that I can really catch the airfoil.
Well, check out her plane and see how your plane might compare to that plane. So you have mass here, possibly mass here, or even wingtips.
Right.
Here's the way to...
That's how they discovered when dinosaurs were flying.
Let's cut it right first.
Did you collaborate on your design?
yeah, I got some ideas from everyone in the group, and it really helped.
Did you try different plans?
We did. We looked at what other people at the table were doing and came up with some stuff on our own.
Did you record any information about your investigation to share with your friends?
Yes, I wrote down all the steps that we took and the results of those steps.
Do you feel like you had a lot of liberty to make any changes to your airplane design?
Yeah, after testing a few things, I made some changes and it worked better.
How did you feel during this investigation?
I felt very positive. I had a lot more freedom this time around.
I hope this video provided insight into science inquiry. What can all of this mean to you? Great question. As an after-school professional, you have an opportunity to include inquiry-based science projects in your own classrooms. When you engage in your projects, ask yourself, is this fun and engaging for me? How about for your students? Moving forward, the modules will ask you to think about applying inquiry practice to your own teaching. I encourage you to share your ideas with your fellow teachers, parents, and administrators. Let's all work together to create a more inquiry-based science experience for everybody. I hope you had some fun today and saw how empowering inquiry science can be. This is Dr. Chuck Fidler from Wheelock College saying, Roger, you're cleared for takeoff.